Hello everyone. Let's see proof the theorem. Prove that integration 0 to pi by 2 sin raised to 2m minus 1 theta into cos raised to 2n minus 1 theta into d theta is equal to 1 by 2 into beta of mn. And second one, integration 0 to pi by 2 sin raised to p theta into cos raised to q theta into d theta is equal to 1 by 2 into beta of p plus 1 by 2 q plus 1 by 2. Okay, this is the proof. It's a very important question. They will ask for 5 marks. Okay, let's see. First one, we know that definition of the beta function. What is the definition? It's the beta of mn is equal to integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 into dx with the condition m and n are greater than 0. Okay, see here in the first proof we have a x as in the form of sine and the 1 minus x in the form of cos. Okay, and its power is 2. That's why I'm taking put x equal to sine square theta and the differentiate dx, we get a differentiation of x, the dx sine square theta is 2 sine theta cos theta and d theta. As the variable changes, the limit is also changes. That's why if x equal to 0, what you get theta, the sine theta equal to 0. When the theta, the sine theta is when it is 0, if theta is 0. Okay, put x equal to 1, then the theta is what? Pi by 2. That means the sine pi by 2 is a 1. Then only when theta equal to pi by 2, then sine theta is a 1. That's why theta is a pi by 2. And the limit is change 0 to 1 to 0 to pi by 2. Put these all values and x equal to sine square theta, put, we get a sine square theta m raised to 1 and put 1 as it is minus x as a sine square theta raised to n minus 1 and the d theta dx is a 2 sine theta cos theta into d theta. Okay, 2 is a constant, take outside. Okay, see here the sine square theta, the power multiplied with m minus 1, what you get? Sine raised to 2m minus 2 and remaining one more term is there, sine, the power is 1. Then multiply both, that is applying the formula a raised to m into a raised to n, that is a raised to m plus n. Okay, applying that formula, what you get? 2m minus 2 plus 1, we get a 2m minus 1 for a sine. Once again, 1 minus sine square theta is what? Cos square theta. And cos square theta, the power is 2 and n minus 1, we get a 2n minus 2. And then already the cos power is 1, we get a cos 2n minus 1 theta and d theta. Okay, the print mistake, you have not print the d theta, you have to write here. Next, 2 is a constant, take outside, what is this remaining? Integration 0 to pi by 2 sin raised to 2m minus 1 theta into cos raised to 2n minus theta into d theta. Okay, that 2 can be taken in LHS. What you get? 1 by 2 beta of mn is equal to integration 0 to pi by 2 sin raised to 2m minus 1 theta into cos raised to 2n minus 1 theta into d theta. So this is the first proof. Let's see second one. Integration 0 to pi by 2 sin raised to p theta into cos raised to q theta into d theta is equal to 1 by 2 into beta of p plus 1 by 2 q plus 1 by 2. Okay, already you know that first one is what? Integration 0 to pi by 2 sin raised to 2m minus 1 theta cos raised to 2n minus 1 theta into d theta is equal to 1 by 2 beta of mn. But the power you have to prove is what? In second, in the form of p. That's why I am taking, put 2m minus 1 as a p and 2m is equal to p plus 1. Notice the m, we get a p plus 1 by 2. And the same as 2n minus 1 as I consider as a q, we get a 2n minus 1 equal to q, we get a 2n is equal to q plus 1 and n equal to q plus 1 by 2. Put this value in the first proof, that is the put, we get a integration 0 to pi by 2 sin raised to 2, the m value is p plus 1 by 2, the minus 1 theta into cos raised to 2, n value is q plus 1 by 2 minus 1 theta d theta is equal to 1 by 2 beta of the m value is p plus 1 by 2, n value is q plus 1 by 2. Solve this, we get a 2 get cancelled in LHS for a sine power. The minus 1 plus 1 cancel, we get only p, and the same as the LHS in cos power, 2 get cancelled and minus 1 get cancelled, we get only q. Therefore, integration 0 to pi by 2 sin raised to p theta into cos raised to q theta into d theta is equal to 1 by 2 into beta of p plus 1 by 2 q plus 1 by 2. So, it's a very important question. They'll ask for 5 marks question. Okay. See here, if they ask first term, the first part, then you have to prove only up to up to first part. Okay. If they ask for second term, that is the second part of the integration, that is in the form of p and q, then you have to write in exam and first and second part both, because it's a 5 marks question. You have not direct write sin raised to 2m minus 1. You have to prove first sin raised to 2m minus 1. Remaining you have to prove in the form of p. Okay. It's a very important. Let's see some examples. Evaluate integration 0 to pi by 2 sin raised to 5 theta into cos raised to 6 theta into d theta. Okay. See, applying the second proof, that is the this is standard formula. Okay, that is the integration 0 to pi by 2 sin raised to p theta into cos raised to q theta into d theta is equal to 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. Okay. See here comparing the LHS and the proof, the standard formula, we get p equal to 5 and q equal to 6. Apply that, put that value in the formula, we get integration 0 to pi by 2 sin raised to 5 theta cos raised to 6 theta into d theta equal to 1 by 2 beta of p value is 5 plus 1 by 2, q value is 6 plus 1 by 2. Okay. And 1 by 2 beta of, solve this is, we get a 6 by 2, that is a 3, and here 7 by 2. Here applying the relation between beta and gamma function formula, that is the beta of mn is equal to gamma m into gamma n divided by gamma m plus n. We have to put using that formula. Okay. What you get? That is the gamma 3, 1 by 2 is a constant as it is, gamma 3 gamma 7 by 2 divided by gamma 3 plus 7 by 2. Okay. 1 by 2 as it is. See here, one important note here I am telling to you. If gamma in the form of integer value, because in the form of gamma 3 is integer, then you have to apply the formula gamma n is equal to n minus 1 factorial formula. Okay. If gamma in the form of rational, in the form of p by q, for example here gamma 7 by 2, then you have to use gamma n plus 1 equal to n gamma m. You have to use that formula. Okay. See here, gamma 3 is the integer, you have to applying the n minus 1 factorial, that is the 3 minus 1 factorial, and gamma 7 by 2 as it is divided by gamma 13 by 2. Okay. 3 minus 1 is a 2, 2 factorial is 2. 2 get cancelled, remaining is gamma 7 by 2, gamma 13 by 2. See here, both are not get cancelled. Okay. But you know that in the factorial you have to taking the up to least term, then cancel both in the form, like only here also for a gamma, the numerator 7 is the least, 13 compared to 13, that's why gamma 7 by 2 as it is. Okay. Gamma 13 by 2, see here, I mean inside we have to step by step explain here, right here. See here, gamma 13 by 2 can be rewritten gamma 11 by 2 plus 1. Okay. Applying the formula gamma n plus 1 equal to n gamma m. Here n is 11 by 2. We get 11 by 2 gamma 11 by 2. Okay. Once again 11 by 2 is a constant. Gamma 11 by 2. 11 by 2 can be rewritten 9 by 2 plus 1. Okay. Once again applying the formula gamma n plus 1 equal to n gamma n. Okay. Then 11 by 2 gamma 9 by 2 plus 1 can be rewritten 9 by 2 gamma 9 by 2. Okay. Continue the process up to we have to final 7 by 2 up to 11 by 2 as it is, 9 by 2 as it is, 9 by 2 once again rewritten 7 by 2 plus 1. Applying once again a formula gamma n plus 1 n gamma n. 11 by 2 as it is, 9 by 2 as it is, gamma 7 by 2 plus 1 as a 7 by 2 gamma 7 by 2. These will put in the denominator we get a gamma 7 by 2, gamma 7 by 2 get cancelled. Then take 2 into 2 into 8 we get a in numerator, and 11 into 9 into 7 is a 693. Okay, so this is the example. See here, in exam you have to ask in the integration in the form of sine and cos, you have to use this formula, standard formula. Okay, let's see one more. These are similar example, try yourself. Let's see fourth one. It's a very, very important question. Okay, they will ask for exam more time. Prove that integration 0 to pi by 2 integration 0 to pi by 2 square root of tan x into dx is equal to pi divided by square root 2. Okay, see here it is in the form of tan, but we know the formula in the form of sine and cos. That's why that integration in the form of, you have to write in sine and cos, that is integration 0 to pi by 2 integration tan can be rewritten in the form of sine cos. It is a sine x divided by cos x into dx. Okay, then in the separate that terms, integration 0 to pi by 2, numerator sine raised to the power is 1 by 2, the denominator term cos x take in numerator, that in the power is minus 1 by 2 into dx. Okay, now apply the formula, sine raised to p theta into cos raised to q theta d theta equal to beta of p plus 1 by 2 q plus 1 by 2. Applying that formula, see here 1 by 2 as it is, beta of p is 1 by 2 plus 1 by 2, and the q is a minus 1 by 2 plus 1 by 2. Okay, 1 by 2 constant as it is. 1 by 2 plus 1 it is a 3 by 2 divided by 2, it's a 3 by 4. Okay, minus 1 by 2 plus 1 is a 1 by 2 divided by 2 is a 1 by 4. Here once again applying the relation between beta and gamma function. Okay, 1 by 2 gamma 3 by 4 gamma 1 by 4 gamma 3 by 4 plus 1 by 4, that is the directly 4 by 4. Okay, that's the gamma 1 is 1, remaining get 1 by 2 gamma 3 by 4 into 1 by 4. See here we do not cancel the terms, and also it is not in the form of 1, the denominator in the form of 4, not a 2. Okay, if the denominator in the form of 2, we have a standard formula, that is a for a least we have to continue the process. Gamma 1 by 2 is a square root of pi, we have to apply that form, but here it is in the form of 4. That's why if the term, see here I will in previous, the denominator power is 2, 13 by 2 7 by 2. Now that time you have to apply the procedure in the form. Okay, in this form, if the denominator fraction p by q, the denominator not in the 2, then you have to use this formula, that is the gamma n into gamma 1 minus n is equal to pi divided by sine n pi. Okay, once again I will explain. If gamma in the form of p by q, then the denominator is equal to 2, then you have to apply the procedure this type. For first one I will explain in previous. If not equal to 2, then you have to apply this formula, that is the gamma n, gamma 1 minus n is equal to pi divided by sine n pi. This is the proof is there, I will send you last time, it's not important, that's why I am not explaining. I am telling the formula, that is the gamma n into gamma 1 minus n is equal to pi divided by sine n pi. If you want the proof, I will send you last. Okay, applying this formula now here, gamma 1 by 4 as it is, this 3 by 4 can be rewritten 1 minus 1 by 4. Okay, applying that formula, gamma n, gamma 1 by n is a pi divided by sine n pi, n value is a 1 by 4, apply 1 by 2 as it is, pi divided by sine pi by 4. Okay, 1 by 2 as it is, pi by sine pi by 4 is the 1 by square root of 2. Then solve this, we get a pi divided by square root 2. So this is the solution. It's an important example. Let's see. This step the example already you have to solve. The fifth one is also similar. Okay, fifth, sixth. See here, I will explain. These are all similar. take this one. Okay, see here they have a, or you have to use this one or this one. Take any one of them. I will take this one. Let's see from this. See here, show that integration 0 to infinity x into e raised to minus x raised to 8 into dx, integration 0 to infinity x square e raised to minus x raised to 4 into dx is equal to pi divided by 16 square root 2. See here we have a 2 integration. Okay, if the limit is 0 to infinity, you have to apply the gamma function definition. Okay, in the form of e raised to minus x, that must be a gamma function. You have to use it. Okay, see here you have a 2 integration. That's why I am taking first integral separate and second integral separate and multiply both. Okay, this is the easy way. Otherwise you have to directly apply. Here also 2 integration, they are directly taken here. Integration, the limit of putting the different values. The easy way you have to, if you do not have a confusion, best way you have to take first integral first and second integral second term. Okay, see here first integral is what? Integration 0 to infinity e raised to minus x raised to 8 into x into dx. It is in the form of gamma definition form. But what is the gamma function? Gamma n is equal to what? Integration 0 to infinity e raised to minus x, but the x here minus x raised to 8 is there, and x into dx. For that I am taking put x raised to 8 equal to t. And what is x? X equal to t reciprocal t raised to 1 by 8. Okay, differentiate dx, we get a 1 by 8 t raised to 1 by 8 minus 1 dt. Okay, as the limit changes, x equal to 0 we get a t equal to 0, x equal to infinity, t is equal to infinity. Put that values on first integral, we get a integration 0 to infinity. Okay, next x raised to and e raised to minus, that is the e raised to minus t, and next x value is what? X value is t raised to 1 by t. So here first they have to take an x value. Once again I will explain. Integration 0 to infinity, x as a t raised to 1 by t and e raised to minus x raised to 8 is a minus t, and dx is what? 1 by 8 t raised to 1 by 8 minus 1 into dt. Okay, 1 by 8 is a constant, take outside, remaining is take t raised to 1 by 8 plus 1 by 8 minus 1, taking all power in first, and e raised to minus t dt as it is. Okay, solve this, we get a 1 by t 8 integration 0 to integration t raised to 1 by 8 plus 1 by 8 is a 1 by 4 minus 1 and e raised to minus t dt. Applying the definition of the gamma function, what is the formula? Gamma n is equal to integration 0 to infinity e raised to minus t or e raised to minus x, x raised to n minus 1 into dx. For x it is a t. Okay, for n we have a 1 by 4, that's why it's a 1 by 8 into gamma 1 by 4. It's a for a first integral. A similar way take second integral. Integration 0 to infinity x square e raised to minus x raised to 4 into dx. Okay, see here the x power is 2 and the e raised to minus x raised to 4. See, here not taking the smallest power. Here we have to definition is what? Gamma function, gamma n is equal to e raised to minus x, x raised to n minus 1. Okay, for that I am taking x raised to 4 equal to t, and x is what? T raised to 1 by 4, differentiate dx, we get a 1 by 4 t raised to 1 by 4 minus 1 into dt. Okay, as the limit changes, as a variable changes, x equal to 0, t equal to 0, x equal to infinity, t equal to infinity. Apply these all values in the second integral, we get a integration 0 to infinity. Okay, x is a t raised to 1 by 4 raised square e raised to minus t, dx is a 1 by 4 t raised to 1 by 4 minus 1 into dt. Okay, 1 by 4 is a constant, take outside, remaining is integration 0 to infinity t raised to, okay, here 1 by 4 is to 2, 2 ones are 2, 2, so we get a 1 by 2 first, and second term is a 1 by 4 minus 1 e raised to minus t into dt. 1 by 4 integration 0 to infinity t raised to 1 by 4 plus 1 by 4 and 1 by 2 is a 3 by 4, take LCM, we have to solve it, minus 1 e raised to minus t into dt. Once again applying the definition of the gamma function, gamma n equal to integration 0 to infinity e raised to minus x t x raised to n minus 1 into dx. Here n is a 3 by 4, therefore 1 by 4 into gamma 3 by 4. Now we have to take this in the multiply both, we get a LHS part. Multiplying both, we get a 8 4 the 32 and gamma 1 by 4, gamma 3 by 4. See here, gamma, it is in the form of P by Q. Okay, P by Q, and the denominator is a 4. Now that time we have to apply the formula is what? Gamma n, gamma 1 minus n equal to pi divided by sin n pi, that formula. Okay, the 3 by 4 can be rewritten 1 minus 1 by 4. Applying that formula, we get a 1 by 3 by 32 pi divided by sin pi by 4. 1 by 32 pi divided by sin pi by 4 is 1 by square root 2. Okay, and the square root 2 takes all, we get a pi divided by 16 square root 2. So this is the proof. This is also similar examples. Take first integral. It's a very important examples. They will ask us 5 marks. If they given two integrals, you have to take separate first integral first, solve, then second integral solve, and multiply both, we get a RHS value. Okay, this is the simplest way. Otherwise, we have to take simultaneously, but it is a lot of confusion happen. That's why you have to take separate first integral and second integral, solve it and multiply that. Okay, these are all similar example. Okay, see here, these are some similar example. I will told you gamma n equal to gamma 1 minus n equal to pi divided by sin n pi. Proof is there, it's not important, the formula is important. Okay, okay, thank you. So this complete your beta and gamma function. Okay, if you have any doubt, ask me in group. Okay, or personally you have to message to WhatsApp. Okay.